Hi, I created this video to show people how a 5-speed trolling motor works. A 5-speed trolling motor works by switching in and out different resistors in series and parallel with each other and in series and parallel with the motor. This simulation that I'm using does not have a motor icon. It has a light bulb. I set the resistance to 1 ohm, which is really close to what an actual armature is on a trolling motor, at least a 12-volt trolling motor. Right now, you can see that the battery is 12 volts. Typical boat battery is 13.8 volts. We won't play with that, but I left it 12 volts just so the numbers are nice and round and even. Given the values of the resistors, etc., 12 volts is a good round number, so everything works out even. You can see that the circuit is running on speed 1, which puts these two 1 ohm and the 2 ohm resistors in series with the armature of the motor. You can see that the actual armature of the motor sees 3 volts. So that's, a quarter of the 12 volts that the battery is putting out. So the motor will run at approximately a quarter of the speed of full speed, speed 5 on a 5-speed Minn Kota, for example. So at this speed, 3 amps, you'll probably get about 30 hours of runtime on a 100 amp hour battery, give or take. I know you're not supposed to drain the battery all the way down, but just for sakes of comparison, you'll probably get about 30 hours. So if you want to go a little faster on your trolling motor, you would switch your selector switch to 2, which would only put the 2 ohm resistor in the circuit to give you more voltage to the motor. You can see the motor voltage is 4 volts going right to the armature. So your motor spins a little faster. It's about a third of the rated voltage of 12 volts. So you'll get a little more speed than 1, but not as much as speed 5, full speed, 12 volts. You can see that the current is now 4 amps, so you get a little less runtime. So at a 100 amp battery, you may get 20 amp hours, or 25 amp hours, a little less. But you go a little faster. Now, if you want the motor to go a little faster, you have to take out the 2 ohm resistor, and when you switch to knobs, you just put the 1 ohm resistor in. So the next speed setting is 3. So you'll have 6 volts now going to the armature. 6 volts is half the rated speed of 12 volts. So you'll go half as fast as you would at 5, theoretically. And you can see the current is now 6 amps. So the motor will, you'll get whatever 6 divided into 100 is, you'll get, maybe 20 or 19 hours of runtime. A little less, but you get a little faster. So now for speed 4, you'll need to take out the resistors. You'll need to close this switch and this switch and open that one. 1, 2, and 4. 1. You will see now that this is speed setting 4, which puts these 2 resistors in parallel with each other, which really cuts the total resistance to like a half an ohm, or a little less than half an ohm, I'm not quite sure. But you see this circuit comes up, goes through this resistance, goes through this resistor, and now you have 7.2 volts to the armature of the motor. The armature of the motor now sees 7.2 volts, and your current is 7.2 amps. See, this is why I made it 12 volts. So all these numbers will match, and there's no question asked. So now you're running at speed 4, which is not as fast as speed 5, but you're drawing 7.2 amps, which is almost twice as much as the last setting. In order to get the motor to run at full speed, you need to take all the resistors out altogether, which you can do by just closing this switch, and that bypasses everything, because electricity takes the path of least resistance. So you can see there's no current going through the resistors. It's going straight to the light bulb. You see the light bulb is full brightness now, and the motor armature is seeing 12 volts, full battery voltage, and you can see it's also drawing 12 amps of current. So that is as fast as the motor will go, but at 12 amps of current, you're going to get a lot less runtime on your motor. basically, this is how a 5-speed trolling motor works. You can see at speed 5, you're drawing 12 amps of current. You're really going to have a lot less run time than if you were down here on speed 1, only drawing 3 amps of current. So I hope this explains to a lot of people how a 12-volt trolling motor, 5-speed 12-volt trolling motor works, and how you can get a longer run time on speed 1 at 3 amps versus speed 5 where you're drawing 12 amps of current. And you can see at all these different speeds how the armature of the motor is drawing more current. The more voltage it gets, it'll draw less current when the motor has to go through the other resistors. It's 3 volts is seeing the armature, only 3 amps of current. I hope this explains a lot. If you have any questions, ask them in the comments.